What electronics?
RRP electronics.
Oh, so it's going to be one. Yeah.
I guess.
Panel it's na. So you'll be part of the panel, no?
Yeah,
I mean, then I'm waiting for him actually.
okay. So the presentation, just in case if you require presentation, then I have to time my laptop. I'll just have my Saloni research.
त्यांचं कसं करायचं सर?
प्रेझेंटेशनच्या वेळेस ते
सर एकदमचं ह्याच्यातच आहे ना.
Our next session is on strengthening the semiconductor manufacturing ecosystem. The speakers are Mr. Sanjeev Keskar, CEO, Arvind Consultancy. Sir will also be moderating the session today. Then we have Ms. Apurva Raut, CTO, RRP Electronics. Joining us online is Mr. Bing Xue, EVP Global Sales, Alpha and Omega Semiconductor, and Mr. Raghu Panikar, CEO, Keynes Semicon. Mr. Bing, can you hear me? Mr. Bing, welcome once again. Are you there connected? Mr. Bing, can you hear me? Hello. No, he's okay. Yeah. So would you like to just say hello so we know we are able to hear you?
Bing Xue, calling from Sunnyvale, California, US, representing Alpha and Omega Semiconductor.
Okay, thank you. So I hand the session over to Mr. Sanjeev Keskar.
Good afternoon. I know sitting in a session after lunch will be a challenge, but we'll try to make it very exciting. See, Indian manufacturing industry for semiconductor is really going through a very exciting time. The biggest challenge for Indian electronics industry till now was about local value addition. On one hand, because of our 1.42 billion population, our consumption story is extremely strong. We are buying a lot of smartphones, tablets, laptops, then infrastructure projects, energy meters, utility meters, data centers, automotive electronics, industrial electronics, everything is growing in India. And as per various reports, Indian market will be around $400 billion by 2030. In that, around $120 billion is export from India. But again, that export of Apple phone, Samsung phone is growing very rapidly. So consumption story is strong, but you know, currently most of the electronics we are doing kit assembly, be it smartphone, mobile phone, be it consumer electronics, be it hardware, we are getting kits and we are doing only EMS activity. And our average value addition in electronics today is around 15%, 1.5. So if we continue at 15% value addition by 2030, Actual revenue recognition for India will be only $60 billion. Still $340 billion will go out. And that's the reason government has now started focusing on semiconductor manufacturing ecosystem with ISM $10 billion policy, where 50% support is coming from central government and 25% support is coming from state governments. So almost 75% support is coming for wafer fabs or ATMP OSAT or compound semiconductor or display fab, which no other country in the world is offering. So this is a very welcome move because semiconductor contributes 25% of the value chain, and that has to be a very strategic focus for India. Secondly, recently launched the electronic component manufacturing scheme will create passive component, bare PCB ecosystem in India. Again, that contributes almost 15% value. So I think all these measures will create improved value proposition in electronics in India. So this particular session, we are going to talk about manufacturing. In the morning, we talked about VLSI chip design and global collaborations. In the second half, this particular session, we are going to talk about manufacturing of semiconductors. And I'm really fortunate to have three panelists who are really domain experts. Firstly, we have Ken Semicon CEO, Mr. Raghu Panikar. They are setting up a very large OSAT ATMP facility in Gujarat. Then we have Apurva Rautji. She is CTO of RRP. RRP is the first semiconductor OSAT unit in Maharashtra. And recently, you might have read that they are setting up a very large 100-acre facility in state of Maharashtra. So, and then we have Mr. Bing. He is a global sales head of Alpha Omega, which is a very large semiconductor company out of USA. And what IDMs are looking at India when it comes to manufacturing, that perspective we will understand from Mr. Bing. So this is a very interesting discussion that we have two Indian companies who are going to set up OSAT ATMP facility
Recording
and one
in
global
progress.
company who is looking at India as a manufacturing partner. Out of 10 projects which are approved under ISM, there are two wafer fabs, Tata wafer fab and one silicon carbide wafer fab of Ratan Shah in Odisha. But 8 projects are ATMP OSAT. And there are another 2 OSAT where those are not approved by ISM, but they have gone ahead with their investment. And one is RRP and another is Stpi Semicon in Gujarat. These 2 projects are not yet approved by Government of India, but still they have gone ahead and set up their OSAT facility. So overall, there are 12 to 14 projects for OSAT alone are in operational. And I think in another few months, Cairns will be in fully operational in Sanand in Gujarat. So the format for next 30 to 40 minutes is like this. Each Mr. Bing, Apurva and Mr. Raghu, they will have a short presentation of 5 to 7 minutes. Then we will have a panel discussion. So first I will pass it on to Mr. Raghu Panikar to present about Ken Semicon. And Mr. Bing, thank you very much for joining online. I know it's very late for you, but really appreciate you taking time to be here with us today.
My privilege.
Thank you, Sanjeev sir, for calling Cairns onto the dais and then talking. I think we should now start telling that the factories are set up. It is not setting up, it is already set up, right? You take Cairns, you take RRP, you take Suchi, you take CG Power, it's all set up. There's already a pilot production that is going on. So it's now a thing of past that it is all getting set up. Now, having said that, it's very interesting that, there's a lot of association partnership that is going around. You know, I can see Sedemic, who are partnering with us, and also, you know, they've been doing wonders in India. I mean, no doubt they're called the Bosch of India and stuff like that, right? So we have Sir, who's been supporting us. We have Alpha Omega on the call, who are our first customer to do the packaging, and in the next few days, we'll give them the mechanical samples to them on the power MOSFET. And congratulations to you, ma'am, for doing an amazing work in Maharashtra. They said it is 7 minutes, because I have 22 slides. I will do it in 7 minutes. The whole idea is to let the team know, you know, we are tucked away a very small place called Mysore, and we've been in the last 38 years doing electronic manufacturing services. The company started as a contract manufacturing by our promoter, Mr. Ramesh Kannan, and from there the journey started to do contract manufacturing for Wipro, L&T, and all of that. And now, you know, we are a dominant force as far as the EMS is concerned in India, supplying products to automotive, railway, medical, and all of those, and a revenue of close to 350 million. And very soon, we aspire to be $1 billion in the next 2 years. We are valued at 4.8 billion as a market cap, because we got listed 2.5 years back, and some of those statistics. The point of discussion more is the semiconductor manufacturing, which is a $350 million project. And this project is coming up in Sanand. And for want of the foreign audience, it is very close to Mumbai. And you go to Ahmedabad and drive across to Sanand. That's where the project is coming up. Part of this entire discussions is that we are getting a very good support from the central government and the state government. Much to our amazement, or much to the foreign audience or the people coming from outside, and to us also. You know, we've been in India for the last 38, 40 years in the semiconductor industry. We started this journey, a missed opportunity 2-3 times. We keep talking about it. I think this time it is for real. This time it's for real. You should come to Sanand if team have not come. You should come to Sanand and visit some of these facilities to see what is happening in that place. So it is just not, we talk of the subsidy, it is the real project that is happening. Constructions are on, the phase 2 of the project on. I'm sure ma'am will also talk about your projects and stuff. CG Power construction is on, phase 1 is done. So real production is happening in Sanand, Gujarat. As far as setting up the semicon business within Keynes Group, which I said is approximately $400 million group. Within that, we are a subsidiary. Within semicon, we have 6 divisions. Why we believe in this 6 division is that, you know, these are the 6 areas that we can provide solution to a customer. When a customer comes to us to do, let's say, an assembly and test, which will be the workhorse for us, we don't want the customer to go away for other services. Reliability and FA. I met certain few teams here. They were talking about reliability and FA, which started a couple of years back, so we'll offer services. R&D, which is more of the package design, package-based simulation, that's another services. And similarly, you know, AT, SSG, and ODM. This is the package roadmap. Our first customer is Alpha Omega Semiconductor. And as we speak, you know, the products that we are producing for them is an IPM multi-chip module. And there are customers in India and outside of India. More primarily in the legacy domain. We're talking to a few customers in the BGA, flip chip BGA, and certain investment in the segment C, which is photonics. These are some of the test roadmap or the testers that we are buying, because there are test services that we will provide to our customers. And we believe that this would be one of the vertical which will be a services for us as far as the test engineering, NPI, new product development, program conversion between testers and all would be a good services for us. This is the test roadmap, the investment that will happen in the next couple of years, covering the entire, you know, digital, analog, mixed signal, memory, RF, and all of that. As I said, reliability and FA would be another services, which is again a capex intensive, and we believe that, you know, putting such services in India, customers would look at us. We are partnering with Bosch very, very closely to do some of these services out in Sanand. R&D plays a big role. I'm not going to get into details of each of the R&D functions, but the whole idea is that we already have close to 16 PhDs who are working with us in doing advanced packaging, looking at lead frame design, looking at package-based design, and all of that. Some of the technology partnership, technology transfers, partnership with the test companies, some of the partnership with Institute of Microelectronics in Singapore, and 2 companies that we have invested in the silicon photonics. First customer, Alpha Omega, the gentleman on the call, I'm sure he'll talk more about this. In the next few days, you will have 2 of the packages that go out from Sanand to their customers. I think it's in Korea. We will continue to do various other packages, which is contracted for the next 5 years. Second customer is Fujitsu, again in the power domain. Third one is an Infineon. This is localization of the silicon microphone, and this will go to one of the lifestyle products in India. I'm not allowed to take the name, but then this is again localization. This is how the facility looks like from a layout, various parameters. This is the capacity for the unit 1, which is already completed. We're already construction going on for unit 2, and then we look at unit 3. The clean room facility that it looks like. The customer from Alpha Omega visited us, and this is how the landscape looks like, and the machining and all of that. Happy to take questions as I sit down and talk about it. By the way, all of you are welcome to Sanand to see the facility. When you come, there are 2 more facilities you can see along with us. Thank you.
Thank you, Mr. Panigar. Now I request Ms. Apurva Raut from RRP to make her presentation.
Hello, everyone. Good afternoon. First of all, let me start with thanking MCCI for inviting RRP here for this conference. And I'll give you a brief introduction about the company. You must have read a lot about RRP Electronics in the newspapers already. So we are a group of companies, and we started as a defense company. We still are a defense company, and we are pure R&D and manufacturing company for electro-optical equipment which are deployed at the borders. And we are very proud. I do not really boast about it. We are really proud to, say that we are protecting the borders with our surveillance cameras and our optical weapons sites. And then we started a new venture, RRP Drones Innovations, which is again a defense company. We are more into drone in a box, continuous surveillance solutions, and kamikaze drones and nano drones for surveillances. And with our background in R&D and manufacturing and a pure defense company, we decided to get into semiconductors because majorly our products are based on thermal detectors, and these parts are imported from countries like Israel and France. And this creates a lot of dependency, and given the timeline, it always created some sort of hurdles for us to fulfill the requirement for the defense forces. So we decided to get into semiconductor, and we had, before even starting RRP Electronics, we had already started working on thermal detectors, and now we have a team in RRP Electronics to develop thermal detectors. We have started with gallium arsenide-based cooled infrared sensors, and cooled infrared sensors are majorly used for long-range surveillances where you have to have vision at night around 30 to 40 kilometers. And we are also working on microbolometers. These has multiple applications. These are used in weapon sites, and also these lot of commercial applications are coming up for these detectors. Then in 2024, we started RP Electronics, and it's always comes to the resources, training your manpower, because semiconductor is a new field to India, and getting manpower trained for such critical application, it's very difficult. So we decided, let's start from having a packaging industry. Let's start slowly working towards our goal that at the end, we want to have a fab where we can develop and produce these thermal detectors. So in 2024, we started RP Electronics, and we, within like 6 months, we started our pilot production facility. It was inaugurated by then Chief Minister Eknath Shinde and government officials. And also Sachin Tendulkar was there. He is our one of the strategic investors, and also a huge support to our company. So our two of our major project got approved in state government. For one of them is for OSAT for around 12,000 crores, and for FAB it's around for 24,000 crores. So these includes capital subsidy, and lot of incentives are included in the package. We started our packaging facility in September 2024, and now which is already operational. We are already doing production for our technology partner. Currently, we are doing QFN, DFN packages here for our partner in Taiwan. And we have technology tab with one of the companies in Taiwan for BGA packages and advanced packages, which includes embedded chips, fan-out panel level technology. So for our BGA package line will start in December. Currently, we are doing QFN, DFN packages. This is just a picture from our inauguration ceremony, which happened in September 2024. This is our timeline look like for our current facility, which is in Mahape, Navi Mumbai. We have already started with legacy leadless packages, and we are coming up with compound semiconductor fab. We are focusing on developing a thermal detector, and in 2027, we plan to integrate it with our existing systems, our weapon sights and our long-range surveillance systems. Apart from that, we are working more into different packaging, such as flip chip BGS, then fan-out panel level packaging, and SIM card module packaging. And this facility, pilot production facility, will be ready in December. We will start the production for our partners in that. A little bit about our prototype fabrication facility, which was our inspiration for this company. So this is based on compound semiconductor gallium arsenide based technology, majorly used for defense product and space applications. And by 2026, we are expecting our prototype facility will be ready. We are already working towards designing the product. We will start the experiments. I mean, we will start the prototyping the product, and then subsequently characterization and validation will happen. So by 2027, we are expecting that we will have our own sensor, which we can integrate in our own product. This is a little bit about the applications we plan to serve with this compound semiconductor facility. Our major focus is on defense and space. Apart from that, automotive industry, medical, and healthcare system, these sensors can be deployed. So our pilot production facility, which is focusing on producing QFN, DFN packages. So few pictures I would like to show you where we are doing our production right now. So we have two clean room, front of line and end of line, and these are few pictures from our front of line production. And end-of-line production. So in front of line, all the processes up to wire bonding is done in front of line clean room, and in end of line clean room, all the processes starting from molding and final packaging are done in that clean room. So everyone knows that semiconductor facilities requires a lot of resources, power, water, and different kind of gases. So to support all the complete facility, the pilot production facility, we have a utility support system at the back of our facility, which includes ultra pure water system, then nitrogen generation plant and compressors, and everything is at the back of it. The key sectors we are right now catering to, so there are industrial applications we are catering to, then consumer electronics and telecom applications. So this facility, in this facility, we are also catering to defense sector, medical, chips required for medical devices, energy, for renewable energy, and in future we are also cater to computing as well. When we are planning to have an advanced packaging facility for wafer level, fan-out wafer level packages, when we will start catering to, manufacturing GPUs, AI-based chips. So this is our current expansion in our facility. We are going to have a flip chip BGM assembly facility. Majorly, we are focusing on imaging, surveillance, and automation, industrial application, consumer electronic applications. In the same facility, we are also going to have a line to package SIM card modules, and not just SIM card modules, or the security ICs for payment and IDs. All these modules will be packaged in RRP. In future, we are going to have, we have already signed MOU with Deca Technologies, and for setting up advanced packaging, fan-out wafer level packaging. This is majorly will focus on AI chips and GPU. And this is based on adaptive patterning technology, in which there are few advantages over the older advanced packaging, that you can correct, you can adapt the mismatches between two chiplets. As you must have already seen in the news, that we have been allocated a land in Taloja, additional MIDC, for our bigger facilities. In our 100-acre land, we are coming up with a fab. So it will be majorly focused on power-based device, power. Yeah. Oh, wait. Yeah. Yes, it's done. So these are targeted application. It's the fab will be dedicated for power electronics, and majorly on RAF silicon on insulator devices, and BiCMOS, and silicon photonics as well. So yes, this is all about RRP. If you have any questions, so just you can ask.
Thank you, Apurva. Thanks, very nice presentation. Now, I will request Mr. Bing to really bring the perspective of the global company, how they are looking at India for manufacturing partnership. So, Mr. Bing?
Yeah. I tried to bring up my slides. I'm not quite sure if you can see.
Yeah, we can see your presentation. Thank you.
That'd be great. That's great. Hold on.
Yes, sir. Please go ahead.
Okay. So I really appreciate this opportunity for me to participate in this MCCIA. And I have to say thank you to Sandeep for the invitation, and also Manish from Sedamac to bring me into this panel discussion. And Alpha Omega is a story that we start with only 8 people 25 years ago, and grow in this 25 years to be like $800 million company. And the company location, the headquarter location is in Sunnyvale, California. And from the 8 people, now we have like over 2,000 employees. And the revenue is about $700 million. And Alpha Omega start off as a design house. And then we grow in the different phases, become an IDM company. So we have our own in-house 8-inch fab in Oregon, US. And then we expand the 8-inch fab to 12-inch fab, joint venture in Chongqing, China. In the beginning, we also work very closely with the OSAT, and then we build our in-house assembly in Shanghai, China. So Alpha and Omega mainly focus on solution, power discrete, power IC, and module. And just like Mr. Paniker mentioned, we'll start working with CANS as its first customer. And the product mainly is a multi-chip module for the home appliance application. So Alpha Omega is a technology company, and we're really have a in-depth knowledge of application in the different kind of power semiconductor conductor applications. At this moment, Alpha and Omega has multiple locations in US for power IC design offices. And also we have design facilities in Taipei, as well as in Bangalore. We started maybe 2 years ago about a design facility. And we expand our OSAT collaboration also in Southeast Asia as well as India. So we expand our business in the different regions, such as United States, Europe, Taiwan, mainland China, Japan, South Korea. And in recent years, we expand very rapidly in India. So we have many customers on the e-mobility as well as home appliance. So I just want to give a little bit of highlights of application for our MOSFET solutions. So our application mainly on computing, power supplies, motors, battery management, and telecom, solar, automotive. And for the power IC, I think everybody knows the current really hot spot is AI. So we provide the V-core solutions for CPU, GPU, controllers, and also power stage. So we're like a total solution providers for the computing as well as other power needed applications. We also provide product and a solution for silicon carbide related products. The target application mainly on automotive, new energy, industrial, and AI powers. So I hope this is give a very quick snapshot about Alpha and Omega. Thank you.
Thank you, Mr. Bing. So let's start understanding What are the challenges to set up manufacturing of semiconductor in India? Mr. Raghu Panikar and Ms. Apuva, we don't have previous historical industry presence, particularly in this high-tech manufacturing industry of OSAT or wafer fab. So getting the right talent or even finding the customers, because fabless ecosystem is hardly exist in India. So your customers are going to be global customers. So how you are going about firstly addressing the challenge of getting the technology know-how, technology partnership, getting the right talent in place, and then eventually getting the customers? Because it's a very large investment you both are doing into this particular manufacturing setup. So, and there are many people who are aspiring to even enter into similar type of business. So what are those challenges? I would like to understand from both of you.
So, Sanjeev ji, everything was a challenge. The challenge started with writing the DPR, right? Writing the detailed project report for the management and for the government. Then a little bit of learning, because since we are from a EMS background, construction was not a challenge because we know how to construct. The clean room could have been a challenge, but then we draw parallels from the pharma industry. We could get some people who have worked in that industry to help us to set clean room. The people who have done IMEC Belgium clean room, we got associated, so we could learn from there to set that up. The technology partner was a challenge because at some point in time, let's say 2.5, 3 years back, nobody wanted to work with us. I'm not talking of the bigger groups like, I'm sure Tata and all have their own problem. The folks in Taiwan didn't believe that we will do something here, whatever we reached, so that was a challenge. I think we waded through those problems. We went and looked for partners, and we got lucky at some places. We got associated with a few of them because of the pedigree. Then you said about the people. That was a challenge because we don't have a large ecosystem or base of operators or engineers who worked on all these processes. But then we got lucky because we got some people from Stpi Semiconductor. We got some expats from Philippines, Penang, and those places. Our association with UST, who is a dominant player in the IT services, they have a large semiconductor division. That helped us to get some people from outside of India. We did an amalgamation of the expats that came, the local people that we had, and then we hired a few freshers. We had to get people for costing because we have never done a pricing for semiconductor packaging in India, so we had to get people from outside. We had to get a whole lot of these debts, right? So that was a challenge, but somehow I think we went past that. Now the bigger problem was to get customer because, customers, to whoever we had gone, the first question is that, is this for real? Will it happen now? So we had to go past that. Every quarter we will go and present what is happening. So slowly, I think we got lucky there to get aligned with Alpha Omega. And once you have one, right, then it becomes easier for the second and the third and the fourth. On a hindsight now, when you look back, it was a dream to reach here. I think it is still a dream to go past next 1.5 to 2 years where we would replicate this now. Because the main plant for all of us would, now we are close to 80, 90 people. To get into 500 would be another challenge. And then from there, get into 1,000 would be another challenge. Then it's a revenue issue, right? Now, all this investment is going on for the last 2.5 years. So management and the shareholders, and one of my earlier board members is here. So, so there was a challenge. We have to explain to the board what we are doing. And luckily, the board was a technology connected people. So they understood what we are doing. they were connected with the manufacturing, so they knew what we were doing. So, we went through those investments, we went through those approvals, and we are here at this point in time to say that, it is for real. The production is happening, and you should come to Sanand or to Maharashtra to see it is happening. All in all, it was a challenge, and the challenge continues.
So yes, it was a challenge for us too, being only company in Maharashtra to have a semiconductor manufacturing facility. We had to go through a lot of struggles, and obviously we had very short timelines. Within 6 months of time, we started our pilot production facility. And coming from I come from R&D background, I come from technology background, getting into semiconductor manufacturing, bringing right people in and hiring people. In the beginning, it was a challenge, but eventually we could create a good blend of experts and experienced guys and young talent who are right now handling all the machineries in RRP. I feel the major challenges, I guess everybody is going to continue to face is getting raw material, consumables inside the factory, because everything is imported. And to my experience, custom officers are still not much aware of what is it. They do ask a lot of documentation, they do not understand the urgency. I'll give you one example. For example, a die attach paste which has to keep it at like -40°, which comes in dry ice pack. We have to get the shipment out as soon as possible. We have like timeline of 3-4 days. And the good part is we are in Mumbai, very close to airport. So that is a plus point. Where we struggle is to make a custom officer understand this is something we require urgently, and you need to clear it. They start questioning it. Why do you need this? You need to give this document, that document. So I guess it starts from there. Government has to create some policy or educate custom officers until and unless we have ecosystem here to manufacture consumables. And obviously all these companies will take time to come in India to manufacture all these raw material consumables here, because obviously they're going to look at the volume. If India is going to generate enough volume requirement, then only they will come to India. So I guess for a few more years, we are going to face this hurdle, getting gold wires, getting some perishable items in India. Apart from that, I guess in infrastructure, in the current clean room, we did it with a local team with whom we were already working on the clean rooms. They have background of pharma industry. Because of pharma industry, the companies who are building the clean room, they have fair idea about creating a very strict compliances. But semiconductor has a different requirement when it comes to ESD management. So we need to educate them that you have to do it in this way. So it was a learning curve for us as well, for our vendor as well. And now we have one template ready. So when we are expanding our facility, it is easier for us to take a decision to plan it for a bigger facility. So I guess these are the challenges we faced and we are going to continue to face in future.
No, this is great. I sure it is definitely very courageous to have such a large investments and completely new sector which is emerging in India. Mr. Bing, next question is to you. You already have a established supply chain in US, in China, okay, and you also head the sales operation for AOS. So whether your decision to partner with Kane System for your packaging requirement is based on the India market demand for MOSFETs and IGBTs and IPMs, or it was purely a business decision? How you arrived at this decision? Because we want to understand what is the thought process of global IDM when they are looking at India for manufacturing partnership? What is the thought process goes with the global players? Because that is very critical for Indian manufacturers to understand.
Yeah. So before I get into this answer, I want to just add a comments on what Mr. Paniker and RP just mentioned, starting the semiconductor industry manufacturing the challenges. Because AOS went through these challenges in this 25 years. And I want to add maybe three aspects. I think the first aspect is entrepreneurial spirit. I think no matter what Mr. Paniger shared, you know, the board has the support, but the spirit to start a new business is the number one. Of course, the second one is the money, right? The third one is the talent. I think once you have a determination to grow semiconductor business in India, you have to pass through these three aspects. And AOS, when we first started as 8 people, we went through all this process. We have nothing, only talents and first investment money, and then we start building the business. So step by step, with endurance, I think both of our company and also the semiconductor industry in India will be success. It's just giving time. But for AOS, the reason we start working with OSAT like CANS, of course, is related to the business in India, as well as globally. We see the consumer, the market grow like crazy, right? I mean, if you look at from like a few years back until like year 2030, I think there's a multiple growth in India. And I have been India like 7 times in the past 6 years. And every time I saw the difference. So I think the market demand is a given. At the same time, I think with the benefit of manufacturing in India, there's like a cost benefit as well as the supply chain benefit, right? So I think because the geopolitical challenges and our end customer also looking for multiple like supply locations, India is definitely has a great advantage. Yeah, that's our thought process.
Thank you, Mr. Bing. We have another 5 to 8 minutes to close this session. I would like to now understand if anyone from audience has a question, please raise your hand, and there are a few mics here. Can you please get the mic? So if anyone has a question for the panel. Yes, Nathu sir.
I just simple question to both Raghu and Apurva. Looks like both the companies, they are doing fantastic on the technology aspects of it. Looks like the challenges of going through the procedural part of customs, excise and all kind of thing, there has to be much more than the technology challenges. So that's something actually what MCCI or maybe government or STPI kind of people, they should really look at it. 40 years ago also the same challenge were there, and in 2025, similar challenges are there, and that is a sad part of it.
Actually, I started my career with a government fab in SCL Chandigarh. So I can really compare the two worlds. 1991 and 2005. Things have really improved, honestly speaking. The reason is that, the area in Sanand, since it will be largely export, we are putting an SEZ there. And now SEZ was an afterthought for all of us, Micron, us and CG Power. And when we decided to put an SEZ, then there is a developer SEZ, there is a unit SEZ all put together. I found it very, very encouraging by the SEZ officers. I'll give an example. Since we got the developer approval and we are in the last phase of sending our samples to Alpha Omega customer, they were very, very helpful. In 1 hour, they let us know a workaround to send the samples, right? So I'll just leave it at that. But then those are the support that they are giving us. I know there are challenges that ma'am mentioned about, the raw material. There's a similar one, like you explained. This was 10 days back at a point in time when the samples have to go. But having said that, the customers have played a very, very big role. Alpha Omega sent their engineers and directors to our facility for a good 15 days and 1 month from a training standpoint. Right now, as we speak, there are 2 engineers coming from US. So, all in all, people have stepped up and helped and supported. So I think it's a long way to go, but I think it's a very positive feeling. But then, yes, this business is not for, light-hearted and faint-hearted people. So, or else you will die every day. There is fun out there, honestly speaking. I think both of us, you would have seen that even though we say it's a challenge, it's fun out there, honestly. So, yeah.
Saili ma'am.
Hello. I represent an incubation center and I wish to ask something on behalf of the budding startups. Now, both of your companies have passed on some challenges. However, there are still some startup aspirants who are still hunting for some good problem statements or some low-hanging fruits which they can catch up and start up with. What will be your input to them? From where to start? Or will there be any support from your side which will be given so that even if they start, you'll be there or somebody will be there to handhold?
So there are a lot of opportunities coming up because even if this is what people think is like OSAT is just manufacturing, but it requires a lot of skill set and also need to have a design capabilities. When we are developing new products, so the package design, the substrate design, this sort of skill set India still does not have. We had to train our people to design the packages and substrate and whatever tools we require. So I guess the startups who are aspiring to be in semiconductor industry, apart from into VLSI design, there are a lot of opportunities to get into different kind of design which are supportive to fabs and OSATs which are coming up. Right now, everybody is focusing on export market. All the chips, with even what we are manufacturing, are being exported. But we need to focus more on R&D to develop our own products. Then only I feel the companies who are coming up with the fabs and OSATs, they will get better opportunity in India. They will manufacture for India. They will supply in India. But yes, R&D requires a lot of patience. I have gone through that journey. For many years, 4 or 5 years, I've been working in power electronics and I was handling R&D department. For these 7 years, we did not have any output. So it's a game of patience. You have to be patient. You have to work really hard, and only after that you will develop a small thing which can be beneficial, which you can manufacture or get it manufactured in the coming of facilities. So I guess we need to start focusing more on to developing our own products now, because right now even the fabless industries are more divided. We are still not. I haven't still seen a product which is completely developed in India and which is in a market.
Yeah, definitely that's a big challenge for India. 20% of global semiconductor workforce is working in India, but we hardly have any fabulous companies which are successful from India as of today. So hopefully the Design Link Incentive Program, DLI program and Chip to Scale program, and the next session is about that particular activity of fabless ecosystem will create more and more fabless companies in India, and they will give business to the OSATs in India. Any other question? One last question.
Hello, sir. Hello, ma'am. This is Yogesh from Voltic Semicon.
Okay, we have seen two hands, Jaya ma'am, and yeah, we will take two questions.
I want to ask you regarding the raw material development in India in regard to semiconductor domain. How these efforts are being put together, to make an ecosystem reliant in India. Let us consider gallium arsenide, silicon carbide, or analogous raw material.
Raw materials, so you're talking about the wafers which will be used in, I guess there are a few companies who are planning to have silicon crystal growth and silicon carbide crystal growth. But I guess once these companies will see the volume, the fab facilities are consuming, I guess more companies from outside India will come to set up a facility here. And I feel government has already have a scheme for supply chain companies who are into raw materials and consumables, and they are also giving incentive for them. So I guess it will take some time for them to come up. They also have to have a business plan. They have to see the future market here. So I guess within like few years, we should see the manufacturing plant being set up.
Yeah, Jaya ma'am, we will take last question.
Yeah, actually you have spent so much money, or you are spending so much money. You go to the board, you go to the government. Are you asked any time the question that what time you will be break even, and what will be the real business? You will get like the fabs or the OSATs will be 100% utilized. Do you have to answer these types of questions in the meetings, or it is just in the development phase that go continue and we will do it later on?
Not really, ma'am. My ex-board member is here. So the barrage of questions that he used to ask me 1.5, 2 years back was that when will you recover money? So nothing is free here, honestly. So we have to break even. At this point in time, all the break-even calculations are all on Excel sheet, right?
Because yeah, but Excel sheet calculations you have to produce and project somewhere.
True. Excel sheet is very easy to manage. You can show it 1.5 years, you can show it 3 years.
So according to your Excel sheet, where you feel that...
No, I get that. Yeah. So the Excel sheet shows now 2.5, 3 years, right? No. But having said that, the business has to have its profit margin and stuff. So we see that 2.5, 3 years we will be able to break even. There are two kinds of Excel sheet, one with subsidy, one without subsidy. So the business has to be without subsidy. You cannot be dependent on a subsidy and then run a business.
Absolutely.
Subsidy is only adding to it. So yeah, there are some businesses that you will win without a great margin, because that would lead to another business. But eventually we see that 2.5, 3 years you have to break even this.
Okay. Thank you so much.
Thank you, panelists. I think this was a wonderful discussion. Mr. Bing, thank you very much. I know it's quite late for you. I appreciate you taking time. Thank you, Mr. Raghu. Thank you, Ms. Apurva. And we'll close this section now.
Thank you.
Thank you so much. Very grateful to Mr. Bing for joining us online today. Thank you, sir. I invite on stage Mr. Ajit Chikteri, Group Lead MCCI SEDG, to please felicitate our speakers today. To Mr. Raghu Panikar, to Ms. Apurva Raut.
Visits India every year.
And to Mr. Sanjeev Keskar. Mr. Bing, I just got the input from Sanjeev ji that you keep visiting India and Pune. We would be looking forward to welcoming you at MCCI at your next visit.
Thank you.
Thank you
Love
so
to.
much. We'll take a group picture, please. Thank you, everyone. Next, we have a presentation from the Keller Group. They are a gold sponsor for today's event. I invite on stage Dr. Anurag.
अलग देख
Yeah, so good afternoon, everyone. I think everyone is very curious about why Keller is here, because this is the common question we got at our booth. So I hope I will address your curiosity through this 10 minutes presentation. So I am Dr. Anurag. I am a Chief Engineering Manager for Keller. So we are basically the construction company specialized in the foundation work. So like moving further, I think everyone is aware
Recording
that this
stopped.
is the AI gen of India, and our Honorable Prime Minister has launched the semiconductor mission in 2021 for setting the foundation for the semiconductor industry in the India. So you can see at present we have 10 mega projects, out of which few has been already started the operations, and the first Dholera fab, which is at Dholera, Gujarat, by Tata Electronics, is soon going to operate. So we are basically the foundation construction partner with Tata Electronics for fab Dholera and OSAT Assam. So why our presence is important? Because I think most of the presentation you are seeing is basically from the processing part, but then the construction. So most of the presentation till now you have seen is basically the processes, but then the construction is a very important part of the semiconductor ecosystem. So which is where Keller play a very important role, because when we talk about the clean rooms or the vacuum rooms for the fabrication manufacturing, these are basically heavily loaded processing units with a very stringent settlement criteria. So just to talk about fab building in Dholera, which we are building the foundation, the allowable settlement is just a 10 mm. So if you want to count, it is just this much. So then your structure or the factory shall not settle for its design life for less than 10 mm. Why this settlement is important? Because we talk about lot of investment, we talk a lot about manufacturing process, but if you compromise on the efficiency of the operation, this whole aim is going to screwed up. So this is where construction industry play important role, providing a robust infrastructure for the semiconductor manufacturing. So these are some of the points you can see when you talk about the construction in the semiconductor. These are precision instrumentation manufacturing. The performance criteria for those buildings are very stringent. Then if you are talking about Dolera, it is an earthquake resistance zone very close to the Kutch area, which is basically the highly active seismic zone. So you have to consider all those parameters when you are building a semicon factory. So moving further, we have just one small video what we do basically. Decrease or huh? I have increase, it's not there. Yeah, so I think there is a sound, but it's not there. Basically, we are the world largest foundation solution provider established in 1860. So we have almost completed 160 years. Spreaded across 40 countries in 5 continents, and basically we have three major divisions. One is in the North America, then Europe, Africa, and then the APEC. So these are the solutions what we provide about the foundation. And in India, we are there from past 22 years, and we have handled contract, more than 400 contracts overall India. So we have good command on the geology of the India. So which area can be good for constructing the semiconductor industry, we can do a value addition. So these are some of the mega projects we have executed. So the video what you have seen is the Barmer, HRRL Barmer refinery in Rajasthan. So this is the tier 2 mega refinery where Keller has done the foundation for the various mega contractors. So then Noida, we are doing the foundation work for the IKEA meeting point. So here we have done a very complex excavation of 25-meter depth with a very advanced dewall system. So here the process looks crude, but when we talk about the physical measurement, you need a lot of precision in the construction itself, similar to your manufacturing. So this is from the Khavda, where we are supporting the green corridor in the Khavda, Gujarat region for the green energy. And then the project which I was talking about, the Mundra, here we are developing a foundation, new polyvinyl chloride petrochemical complex, which will cater for the 70% of the PVC requirement of India. So it is one of its mega petrochemical complexes. So this all project what we are showing is basically they work on a very stringent performance criteria of the infrastructure. So we are basically a one-stop solution. So starting from the groundwork, we do design. We have our own fleet for the execution. Yeah, so this is from the OSAT Assam. We are the main foundation contractor for the Tata projects and L&T. So these are some of the aerial views. So we are almost completing the 80% of the work, and soon you will see the superstructure coming out from the OSAT Assam. So this is another portfolio. We are also into the marines, supporting the port development in the India, which is also one of the mission by the present government. So this is basically the early step of any project or any infrastructure projects. So it looks very flat, it looks very dried, but the end product is very beautiful when you see the Worli Sea Link or the bridge in the Mumbai, coastal bridge. So these are some of our values. So these some of the snapshots are from the Katupalli jetty in Chennai. So moving further, I think the introduction about company already given. We are 160-year-old firm. Right now our revenue is roughly 40 billion pound, and we have spread across the 40 countries in 5 different continents. And in India, we are operating under the Keller Asia division. And globally, we have around 9,000 employees, and in India, we have around 2,000+ employees. So these are basically the various foundation solutions which will be requiring in the semiconductor industry. So I will not go into much detail, but yeah. Yeah. So our presence, I told, we are 22-year-old company. We established 22 years back, and we have handled more than 400+ contracts successfully. And these are some of the launching of the various products in India. And these are our clients and our partners in various projects. So we have handled with many stakeholders. Yeah. So now coming to semiconductor industry presence, I will be discussing about our first project, which is OSAT Assam. So this is where we are developing a foundation for 170 acres OSAT Assam building, which comprise of 6,000+ board piles, and the duration for completion of that project is 6 months. Completing, yeah. So this is some of the photographs. This is the first fab building in the Dholera. Right now you can see how the foundation works are going on. So you are operating with 40+ rigs there, installing more than 6,000 piles for the fab unit. We have also a global presence. We have also supported T1 manufacturers, the Dongjin, the Intel, for setting up their plant in Sherman, Texas or Arizona. So these are some of our global share. So I think this I will just keep it. These are some of the projects, landmark projects, which Keller has been part of. So like to sum up my presentation, it's like since most of you will be establishing their plans, so early association with Keller can help you in the cost and the sustainable optimization of your construction. And then we are being a local focus and the global capability, we can deliver complex and big projects with utmost safety and quality. So that's all from us. Thank you.
Thank you, Dr. Anurag. A little felicitation, token of gratitude from MCCI, for which I invite on stage Mr. Milind Jape, core member of SEDG. Before the next session, we would invite on stage Dr. Priya, head of the Semiconductor Department from D.Y. Patil University. She would like to share a little quick announcement with all of us.
Okay, thank you so much, and good afternoon, everyone. I'm Dr. Priya Charles, and I head Semiconductor Engineering of D.Y. Patil International University, Akodi, Pune. I'm honored to share the development of our semiconductor engineering program. Launched last year, this program has been developed with an aim to develop our students with the rich talent pool, I would say, with the requirement of the semiconductor industry needs. So we are thrilled to get a tremendous response for this program with the 60 students last year, and this year we have got an 80 students enrollment, which is a 33% rise in the enrollment. So we were happy to share this to you all. So in order to enhance the students' learning experience, we have established a state-of-art semiconductor fabrication laboratory, which is equipped with a clean room of 10K, class 10K and class 100K. And in order that we skill them, we just wanted to skill them with the requirement of the industry, as I mentioned earlier. And in line with the government initiatives, we have even developed skill development programs and ITA programs for the same. Recently, we signed an MOU with Kane Semicon, thanks to Mr. Raghu Panikar, he was here. We have signed for the collaboration of these skill development programs. And I'm here to extend, on behalf of D.Y. Patil International University, I'm here to extend an invitation to you all for the inauguration of our very first semiconductor laboratory at our university. So it is, the tentative dates would be in the last month of November. I would be taking all your details and sharing the invitation mail to you all. Please do visit our laboratory. Thank you so much for the opportunity. Thank you, MCCAA, for accommodating me within this busy schedule. Thank you. Thank you.
Thank you so much, Dr. Priya. Indeed, a very exciting kind of an announcement. Our next session is on the topic Skilling for Scale in Design. I invite the panelists to please join me on stage. Mr. Dinanath Kolkar, Professor of Practice, COEP Tech University. Sir would be moderating this session today. We have Mr. Bharat Agarwal, President, Vishwakarma University. Professor Mariam Shuzai Bagini from IIT Mumbai. And Mr. S.D. Sudarshan, Executive Director, CDAC. Mr. Vivek Pawar, CEO, Vidyalip I4C. Thank you, everyone. Dina, sir, over to you.
Good afternoon. I hope at least the students are all awake. It's a pleasure to have all of you over here, and it's a very interesting mix of panelists that I have, and privileged to have them here. We have Bharat Agarwal, who represents private universities and has been the chairperson for our MCCI Education Committee, so he has a very big reach in the larger ecosystem in Pune. We have Professor Mariam, who is from IIT Bombay and a very integral person in the CEMIX ecosystem that has been developed, and I was privileged to be in the CEMIX conference and hear the work that they are doing. We have Dr. Sudarshan from CDAC, and CDAC, as you know, is playing a very crucial role in the India Semiconductor Mission as well as the National Supercomputing Mission. So we'd like to have his viewpoint. And we have Vivek Pawar, who has been in the industry in large corporations, and then he also set up his semiconductor startup, played a very crucial role in setting up things inside a campus of BVB Hubli. And now he's very actively involved with skill development in this particular area. So a very diverse point of view we will get. And we have a lot of students out here who are very actively listening to what you guys are saying. So the objective, we thought we will do this session in a way that we have an aspiration as Pune as a city to launch many semiconductor clubs in different engineering colleges. And I met many of these students during the CEMIX conference, and this discussion started from there. And we said, there's a conference coming over here. Let's get all of these guys to work and prepare a draft of what should be the charter for this Semiconductor Club initiative. So I'll start off with Professor Mariam first, because CEMIX has been playing a very crucial role in helping out and taking the lead. And one thing which really struck me when I was there at the CEMIX conference, they presented the university outreach program that is there, and where the IITs have reached in the last couple of years. As compared to that, there is a huge gap that the other colleges and universities have to really catch up. Since we are talking about scaling up, obviously all of these have to play a very crucial role. So maybe you can start off with giving a view around the CEMIX initiatives, as well as what are you doing to bridge that particular gap.
Sure. Thank you, Dinanand. It's because you mentioned about the universities and institutes, therefore I focus on that part and start from what kind of plans and on with respect to IIT Bombay activities, which is eventually extendable everywhere. So there are several, in fact, programs. Let's start from outreach. So several years ago, IIT Bombay noticed that definitely because of the semiconductor mission, the regular programs are not good. Which is the topic of this discussion as well. So outreach programs, and in fact, educational outreach office was established. We had already CEP, continuing educational program, but now it is in the form of educational outreach with different types of outreach programs, courses, and variety of them, some of them with visiting faculty, adjunct faculty, professor of practice. Some of them are with industry, and some of them are a combination of all, and some of them pure with the faculty members. The second thing is that the Semi-X, when X actually represents everything in semiconductor industry, was established around 3 years ago, and now recently, just a month back, it was announced and approved by Senate as an academic center. Now, this is a kind of unique academic center, at least at IIT Bombay, which has a very widespread industry connection. In fact, even programs are defined and designed based on industry, collaborations, internships in industry, and requirements of the industry. And the next thing is that there is a university affiliate program, UAP, which has started with support from government of Maharashtra, and IIT Bombay is a hub for that, and the model of this activity is the hub and spoke model, when the IIT Bombay will develop the nodal hubs, and nodal hubs will get connected to more number of the spokes eventually, and then this will help to have a model of scalability with respect to different domains. Right now, what we are talking about is about design, as well as materials, as well as packaging. As of now, 3 verticals are well defined, and it is not limited to that. On top of that, there is a program by Ministry of Education, which is called DevSet, Development of Talent for Semiconductor Ecosystem. IIT Bombay is leading that activity. That activity focuses on the industry requirements, future technology, anticipation, which was one of the points today, how to see the technologies required in the future in this area, specifically when India can become a leader in those areas. Gaps identification, not only within India, but also at the international level. Also solutions and policies. And therefore, DevSet also provides a different kind of support. And we have started, and it has various verticals. So we have started with verticals such as packaging, devices as well as the analog and mixed signal design. So it includes even electronic systems, it includes even materials. So eventually it considers from A to Z of the semiconductor industry. Now how we are managing all of them together with so many things, that's the model that eventually SemiX is establishing, which is the connection with industry. And I think one thing which is out of all these activities, and based on today's morning also discussions, that one thing that really attracted my attention was the statement by one of the gentlemen who mentioned that we have to move from software to innovation. I think that was a very important statement because, and who is driving that transition? I think, in my opinion, are faculty members. I mean, anybody who is having the role of teaching, be in industry, be in academia. Because if we are able to establish the fundamental thinking, then we can establish the fundamental innovation. Innovation cannot come without thinking. Therefore, we need to develop and train thinkers in semiconductor industry. I think nobody looks at that aspect. We talk about manufacturing, design, but at the end of the day, if we want to be the leader and or tomorrow innovative and more self-reliance, naturally there should be semiconductor thinker development. And I just wanted to convey this message as well by giving also a brief overview of the activities which are going on. And this university affiliate program, actually we are inviting, even today I was talking to some of faculty members, inviting even more, because we are going to have this pilot across Maharashtra universities and institutes, and then later it will be scaled up at a higher level because to other states, because under the DevSet program.
So Mariam, I'll come back to you again on how industry can actually help the entire CEMIX effort.
Yes.
But I'll come to Bharat. Bharat, actually you should take a look at the presentation which was done. And I was actually quite aghast with the gap that was there between, they have done a study of IIT Bombay versus all the other institutes and comparison. And if you actually look at, you have a Manhattan Tower and you have a 2-story building. You know, that's the type of difference which was there. And I actually was not really believing in it, but the last few days, I have been going to various institutes to celebrate IEEE Day and things like that. And you know, they host me along with the principal or director, and I asked them the question, how much are you aware of the semiconductor initiatives, the demand which is happening and stuff like that. And I was quite surprised that even, say, ENTC department or the directors and principals are not really aware of it. So, you know, to take that point, you know, since you also chair the committee, so obviously action item would be to have this presentation done to the entire members. But what is it that the academic ecosystem is doing to first create an awareness in the faculty members and the leadership team about the demand that is there in the industry?
Thank you, Dina, and thank you, Maratha Chamber, for having us on this panel. I'm not surprised, Dina, when the statement is made that a lot of things of this on this front is happening, that the IITs and it's the Manhattan Tower over there and the private institutes, universities are nowhere close to it, or small shrubs around it. I think this is naturally the way in a upcoming industry, in an upcoming sector for our country. It is the IITs that would be first getting the rightful research funds, and they would be having those funds to invest. The private institutes, universities normally would follow. So I'm not surprised by that. Anyways, coming to the point, electronics department, and I know you work with the ENTC department of COEP, our ENTC department, and other universities and colleges. I think all the electronics departments of all colleges, private universities in Pune, Maharashtra, are seeing the good comeback in the last 5 years. And I say this because prior to 5 years, all of us were making electronics engineers for the software industry. Largely graduates from our departments were getting better, easier, and good paying jobs in software, which was definitely attractive. Reasons have changed, circumstances have changed, and last 5 years we see that electronics departments are now coming together to have a focus on the domain expertise, domain knowledge, domain content, and domain industries, semiconductor being one of them. So there is a revival of this sector, of this education domain, I would say, in private institutes. Private institutes like VIT and I'm sure COEP and others are now focusing on how do we enable our labs, our faculty, and our students to catch up to this new demand or new talent demand that is going to come up. I see, when we are talking about students, let's understand another that students will never play a proactive game, that they would not like to invest in a talent that everyone is forecasting to be a great job employer after 5 years, 10 years. सब बोलते हैं कि आज क्या जॉब है बताओ, वो हिसाब से हमें कुछ पढ़ाई करना चाहिए. And that is how the way the industry also works. I think in the last 4 or 5 years, one, the faculty have pulled up their swords. All of them are getting the right exposure on the knowledge, content. We are getting good relevant industry connects, industry partners, and recruitments on campus, which is also motivating students to take this up very seriously. I'll give you one example. Lattice Semiconductors from Bangalore came up last year for recruitment of engineers, electronics engineers. They did not find anyone on campus, honestly, on the first round. We asked them, why are it kya gadbad ho gaya? They gave us a few things, a few insights. कि आपके बच्चों को ये 4-5 चीजें नहीं आती है. We went through a short course with our students. They came back after 3 months and they were able to recruit students. So this is a situation all around where we are conscious that this is an area where we need to work on. Our faculty, I think, is competent, only they need the right exposure. We need support from the industry. Students are there. Students have the right exposure and I would say also the foresight to envisage what they want to do as a passion, as a career, and they are taking the right decisions now.
I'll come back to you again on a slightly more broader question, which is more to do with, this industry requires multidisciplinary skills. So what is that universities do to look at not just an electronics department, but also other things? But before that, I'll go to Vivek. Vivek, he is also an alumni of COEP and IIT Kharagpur and spent many years at Texas Instrument, then went on to set up his own startup, and he created a part of his startup, incubated that inside an institute, and over the years, he has done an amazing transformative work. So Vivek, would like to, that's a pocket of excellence, which I think every institute should potentially aspire to have. And we need more people like you, of course, to drive that. But I'm sure this would be a good lesson for many people in the industry who are sitting here, who can potentially explore and support initiatives like what you are doing.
Sure, thank you, Dina, for the question. I think I'll start with exactly 20 years back, I came back from US. Working at Texas Instruments, settled job with family, and all my friends were shocked when I decided to come back to India. But when they realized that, when they found that I'm going to actually Hubli, a tier 3 city, tier 2 college, and starting a company there with all people there, they were shocked, aghast actually. So question will come, why, and I'll talk about that later. But we went to a BEB college, started a campus, in the campus a startup. Our goal was to be a 250 engineer company, because there's no other goal. So we said, okay, let's be biggest analog chip design services company in the world. And Portuguese company called Chip Idea was 200 engineers that time in 20 years back. We said we want to be 250. So there's no other better goal. Fast forward 20 years. What happened to BEB college? We'll talk about that first, then Sankalp maybe. So BEB college, this college was not even in top 500 in the list, neither top in North Karnataka. Forget about in top 15, also not in Karnataka. Today that college has got recognition from MIT report talking about one of the 5 upcoming colleges in the world showing signs of innovation in engineering education. Yeah. Only one college from India, that was this college, recognized. This year, there was a chip design contest across India competing with IIT created by Samsung. Number 1 award went to BEB college. Okay. Number 2 award also went to BEB college. Number 3 went to IIT Madras. So it's competing with IITs, including Bombay, right? They got the top 2 awards. Now it's good to see the story. So that is one. So how did this happen? So how did Sankalp go to college campus? Fundamental thing is, if you look at it in India, whether medical college is in a village or a city, the doctors are amazing. because every college there is a hospital attached. Other doctors from the government college are supposed to be better because they solve 5 times more problem than the private college hospital, because hospitals are big, overworked students, they spend more than 50% time. So when we said, why don't we actually get a startup, integrate with the department in the campus, so students don't do demo projects. They actually solve real problems of industry seeing in the campus from second year. We started that with the college. So first, industry cannot work with the college. It has to be startup because they have a need and they're actually in the campus. Then we started a club for students. So students started joining Prakalp club called Vilesa Club, which I think Dina is talking about, and he's going to start it here. Because without club, the success cannot happen in the college for learning. So Prakalp club was started, and then students started joining Prakalp club, doing kind of projects right from second year. Simple project, band gap reference, PLL lock loop, PLL oscillator, maybe band gap and things like that, right? And then they go, finally projects are industry project using industry tool and industry stuff. Now how does it benefit? So for student, they're getting core jobs. 20 years back, this college used to have 82% IT jobs, Infosys and TCS, and 18% maybe core jobs. This year, and last few years actually, 73% are core jobs, and only less are remaining are IT. And core jobs are not local companies. Texas Instruments has recruited last year 20 people from this campus. It doesn't recruit more than 8 people from any campus anywhere in the whole world. They did 8 first round. They went across India. Second round, they selected 12 people. This year, they realized that they don't have to go to second round. They took 16 people from the first round itself. So what I'm saying is, students have benefited. Startup got benefited. Sankalp benefited definitely. This college has created 150 startups in last 20 years. 2 of them are 200 plus crore valuation. They got exited actually. Sankalp exited with actually not 250 engineers. Our goal was 250. But we became so successful there that IIT Kharagpur called us, which was not willing to take us. So why did I go to BB college? No other college wanted us in the campus. This college was saying that why don't you come, we'll do everything for you. So this kind of college now has created ecosystem of talent so much that Hubli has 6 semiconductor companies, and 2 product companies doing products for India, which will not be anywhere. Now, so we have to have the model. Startups have to come into campus, work with the faculty students. One of the faculty has done a PhD in 21-bit sigma delta I2D converter. Nobody in India has done that, including IITs. And we have done the full simulation with the back end and everything, right? And then she's helping students to understand what industry needs. That's why Texas Instruments is taking, because she's training them on the basics of what industry needs. And finally, now we are trying to copy-paste this model across India, hopefully with support of all of you, with industry. We have made this 20 years model into 5-stage model. We are trying to working with 2-3 colleges now. At 15 colleges, we tried a Vidyali program for skilling. But we want to move, as Madam Mariam said, we have to move from, India has to move from service nation to innovation, we call it service nation, to product nation also. And for us, because of geopolitical situation, and for us to move to product nation, students have to have a product mindset, innovation mindset, and core job interest, and that is what you develop in across India, and that's what our goal is.
So one very key message, one is that for the students, there is already a charter of a club which you can share with them. So number 1. Number 2 is the openness that BVV College had in getting you onto the campus and getting that model. So I think it's, I and Sandeep have been discussing on this particular thing. We have been talking to some of the companies in Pune to encourage them to actually set up things inside of the campus so that some of the students who are at the later part of their career in the college can potentially take benefit, and they can actually help fast track, like what Bharat mentioned, that, giving them a finishing touch, which is more relevant to the industry. So obviously that's a possibility that we can build. I'll come back to you again. Dr. Sudarshan, CDAC plays a very crucial role in various initiatives that the government runs, and specifically the C2S program that is there. And interestingly, when I was interacting with the students at the conference, there were students from some of the colleges were not even aware. So it's likely that it is not known to quite a few colleges. Second is there are colleges which do have all the ADI tools, but the students don't have people to guide them. The faculty members are themselves not trained. So it's a combination part. So one is tell us about the C2S program so that the larger audience knows about it, and what is being done to bridge the gap with the faculty members specifically, if you can cover that part.
Yes, so first of all, glad to see the SEC club we are talking about, because as we go from service nation to product nation, it is important. And coming back to India as a country, when the semiconductor mission that we all hear today, it started at a much smaller scale almost 2 decades ago. It was called the SMDP program, Special Manpower Development Program for Semiconductor. And the first 5-year plan had a target of 350 students to be trained in EDA. That was the beginning, humble beginning that India made. But thanks to the current scheme, it looks at basically 3 verticals as a country. One vertical is related to the infrastructure creation, which we heard about OSAT, FAB and all, which the government directly deals because there is a lot of, one is the scale, second one is the administrative things, space, land, power, other things. On the technical side, they are looking at 2 parts. One part is the capacity building, because we need the right manpower. That is the chip to startup program. But it is closely associated to what just Mr. Vivek told about. How do we enable the startup to get mandatorily associated with academic institutes so that startup also can innovate, experiment at a lower cost in a time-bound manner, because students have an academic cycle to complete their task. At the same time, students should not do low-end projects. They should do something application-oriented. That is what CTS focuses on. But once the CTS has an actual solution in mind, they can join the design-linked incentive as a company on its own, which can grow. That is how it has been conceptualized. So coming back to C2S, our target originally was, over a period of 5 years, 85,000 students to be trained in not necessarily fabless ecosystem, but also do the initial tape out using a MPW, and then subsequently do the post-silicon validation so that the chip is not only packaged but also tested, which can get into a product subsequently. That was the original idea. And then when we started, there were few major things, as we heard from the previous panel also. There is a hiccup when you start. First of all, EDA tools. Each vendor is very proprietary, and they are good in certain aspects, and some are average, some are below, but you have to take a bouquet from one vendor, and that tool, whatever it provides, your institute is bound to it. And what C2S, thanks to Ministry of Electronics and IT and the core committee that helped us set up the whole scheme, CHIP-in, which was conceptualized, the CHIP India as a scheme, we decided that it will not be one tool, but as many EDA tools as possible under one umbrella. So we started with the top popular 3, but today 9 tools, all possible tools in the EDA ecosystem is available under one roof called EDA tool grade. And it is now world's largest such a system under one umbrella. And we support 300 academic institutes. And all of them have access to as many tools as they want. It has also changed the way students are designing using the tools. Now they can compare and contrast. Maybe for simulation, X tool is better. For timing analysis, Y is better. Place and route, Z is better. So we are actually getting a better design. And students also are not bound to one stream. On the other side, you brought that point of talent in terms of faculty. Many institutes do not really know, I agree, because to apply for CTS scheme, the institute has to mandatorily tell what are the VLSI courses they offer and who is the faculty who is qualified to teach. So that is one of the reasons, as I speak, we have only 350 applications. Though we know there are 600 plus institutes offering VLSI courses out of the 17,000 under the Indian scheme of things. So these 350 also, some of them have done their PhD in that area, resume is there, but they have become traditional teaching faculty. So the ecosystem does not exist to support a large volume. But it is changing very fast. For that, I'll give an example. Today, last year we conducted a design hackathon in the month of March, both analog and digital. Surprisingly, 10,000 students applied, forming about 2,500 teams. And we had a hard time shortlisting 40 of them. First time, a 100-hour hackathon was held. And students stayed awake 100 hours under one campus. And we had support from all the vendors, tool vendors and all. They were also there on campus at Bangalore. And interestingly, the top 6 prizes, at least 2 of them went to non-IITs. And Tier 2, Tier 3 students. And one batch is actually second-year students who have not done any course formally. They saw there is a challenge. They saw there is a prize. They saw there is a visibility. They learned on the fly, came and participated and won. That is something amazing. So our students do have the talent. All we have to do is show the right motivation and inclination and give the support. Just a pat in their back and give them access, they will do wonders. And as far as faculty is concerned, thanks to Professor of Practice and other things, we are getting it. Now coming back to what happened. In 2020 when we started, it was all about giving access to the tool. But today, looking at the volume and the kind of manpower that is coming up, I'm very happy to share that we offer something called IEP, Instructional Enhancement Programs. It is being offered by every tool vendor, SCL, which is a fab from India, semiconductor lab, CDAC itself offers, and then there are aggregators like IMEC, Muse. All of them are offering courses, both physical and online. And at any point in time, on the average, 600 man days of training is being provided in any year. So that is the voluntary, training being provided by the owners of the tools, owners of the processes. They are doing it. That is one part. Second part is, now in the previous scheme, it was called C2SD, we had done something like 100 tape outs in 5 years, siliconization. In the current scheme, this year alone, we have already taped out 70 chips in 1 year. And now it is actually time to market, what we are looking at startup. So we don't need 3 to 5 years to do a basic chip. Now we have launched a program. In the last VLIDC concert, we announced. It is called One Tops, 1 tape out per student. A master student, when he joins and graduates, we need a chip in his hand. It is no more paper design. We are trying to get 100 chips taped out in the next 2 years under this program. This is in collaboration with the global foundries, SCL, VLSA Society, CDAC, all put together. So the speed is changing. The mentorship is happening. On top of it, under the C2S, a startup has to be part of an academic consortia. Then they get a funding support to tape out under C2S. Between the startup or the students with the idea to create a startup themselves. In addition to that, we are continuously running every year some hackathon, grand challenges. Anybody can come, not necessarily CTS institutes. But going forward, finally, one question you asked about how to improve the faculty. So we conduct 5-day residential IEP programs for all the academic institutes, instructors to come and join. And roughly, we have about 8 courses every year happening. The number is going to increase. We are expecting a DLI2 and ISM2 announcement very soon. When it comes, the numbers will scale up. So we also have master trainer programs. In addition to that, beyond CTS, for example, we heard about Samsung Challenge today. Similarly, ARM has got its own program. Several state governments, for example, AP government has a very exclusive program on the embedded ecosystem. Companies are all targeting, similar to ARM, Renesas is doing something. Each one is coming up. Synopsys has its own challenge. We are also running India's own processor called Vega processor and Shakti processor. And we are running challenges on developing solutions using our own cores. That is on top of the CTS. So there are parallel activities happening, and hopefully in the next 2 years, we will be a product nation.
So a couple of things which came to mind. You know, we talked about difficulties on mentoring or guiding students, right? And we talked about professor of practice and things like that. And we heard design link incentive or production link. Maybe there should be something related to training link incentives. Organizations who have talent, we talked about 20% talent sitting in India. How much of that talent is really contributing? Can organizations make those people available to train or mentor students, and they can do it remotely? Because a lot of these talent requirements are mostly queries. That's one point, just a food for thought and probably for deliberations as well. The other thing which is there is, so we are talking about scaling, and it's semiconductor industry, and I was having an interaction with Professor Mariam, that I've been through the journey of the IT industry. So IT industry in India grew at the same pace as the world was growing. Semiconductor industry, we are 30 years behind schedule, right? So there's a lot of learning which has already gone. We have mastered the art of scaling with digital technologies. Are we using innovation? Are we disrupting? Are we getting the students to participate in the innovation of having to scale up? So a slightly different and a difficult question, probably point for all of you all, to think differently in the way we are actually wanting to scale up the education ecosystem. What are your views? And probably start off with Mariam, then Bharat.
Yeah, thank you. Actually, very good question. I think one of the ways that this education ecosystem can get enhanced and also scaled up very well. In fact, scaling is not just by quantity. It should be scaling while maintaining the quality. We have to keep the second part also in mind. So for that, I think the best way would be to take advantage of today's technologies. In fact, today, technologies, the training, learning is not same as before. So it's not only from teacher to the students, it's actually from resources to the student. And because of the availability of various engines which are playing the role of teacher, I think this can be done. But still, the role of a key teacher for fundamental thinking and nurturing this seed in the mind of all students with whom, with that person working, is to really make them thinker. I think this is the only point. You just teach one fundamental point to somebody, and that person would be able to just go ahead with that fundament. It's just like establishing foundation of a building. I believe that only thing which matters is that fundamental establishment. Rest of the tools, in my opinion, are available, and easily this scale up can be done. In fact, Sudarshan mentioned about all the plans of the SIDAC even in the future and METI. Plus all these various programs, industry, involved programs, short-term, long-term, internship, and I think scalability is quite possible. Even you talked about clubs. Vivek also talked about the clubs. So I think these are all already in place and will be even scaled up. But I think we need to think about that and see how to make this semiconductor thinker development. Of course, one thing, as you said, many students are self-motivated, but believe, I think you will believe, if we want to scale up, we cannot rely only for those who are coming forward, even without telling them. We have to encourage 80% of the students to really become the real thinkers. Don't think only just, I want a job with this salary, right? And this is mindset of many students, which is true, but at least have that mindset, I want to have a job in which I can grow. If that becomes the mindset, I think everything automatically will improve.
So one interesting thing, Bharat, came up was we had the VLSI Society of India president visiting COEP, and we were deliberating about this, that India just doesn't have the time. We have to really fast track. And we were talking about industry-academia collaboration as a point, and I'm sure everybody has heard this and beaten this to death. But he said, have you guys thought about academia-academia collaboration? And it's a very interesting point, and good thing is, we had the D.Y. Patil professor talk about what Dr. Prabhat Ranjan has done, and they've launched the semiconductor program. And his point was very valid. He said, now if you launch this, every college will create their own semiconductor program. They will have their own board of studies. can academia collaborate and do things at a fast track mode? So is academia ready to fast track with collaboration, not just with academia in India, but also academia elsewhere, across the globe, and how we can actually fast track that, your views on that?
The mindset is ready. I think so. None of us are in that siloed mindset like before that we will do our stuff. Collaboration is the key, and more or less the teams at academia are also aware of it and seeing the benefits of it. One, I come back to industry-academic collaboration first on this topic because you mentioned scaling up. Now, scaling up, I believe, will happen not only on the academia side, but it's as an ecosystem scaling up should happen, which means that companies would also scale up, the government initiatives would also scale up, and the human talent supply would also scale up. And all of this will happen jointly, and we all are very optimistic that this is certain to happen. Academic collaboration, of course, Big Brother IIT Bombay is there next to us, and with then opening up the arms and trying to create a hub and spoke model, I'm sure many institutes like ours and others in Pune, Maharashtra would like to associate with them and tie up with them. Academia tie-up, as good as next Wednesday, VIT is tying up with COEP for association where we'll be signing the MOU for the same program, same sort of a lab which is developed at COEP, and VIT would be, students of VIT would be using it. And abroad, I have examples of companies that have recruited students from India. I give you one example. We have a very strong association with IFM Electronics. IFM is based out of Essen in Germany, and they keep on coming to us, recruit from us, they have students projects. Extension of that, the same extension with IFM has led to an association with Allen University in Germany on development of a research lab in VIT Pune. Now, this is because the same students who were going to Ireland were recruited to IFM, and that network worked out. So, academic collaboration, I think so, is happening larger and more on international borders, because I think so people are more open-minded there, that we have to learn from each other. The universities over there want to learn from student or supply pool from our side. We want to learn from maybe resources or some technical expertise from there. So that is happening, that would grow. We are open-minded to associations between us as well. The ecosystem will scale up, I am very sure, and because of the ecosystem, this human talent development would also be better than what it is today.
No, it's very heartening to know about the opportunities, and this is one example I've seen. There are quite a few GCCs. You've seen a lot of messaging happening around GCCs, and many of them are wanting to contribute. They have their design setups and stuff like that here. So I'm sure that they will also bring in the collaboration from their parent countries. Vivek, to your vision about product nation, and you've been continuously challenging the students about staying core to the fundamentals and building up that. And obviously, we are talking about multidisciplinary skills out here in this context. And you've been very strongly advocating how students should approach things. So give that perspective, since there are a lot of students who are waiting to hear from you. And we will also have you do a session with the students who have joined the club. As of today, there are about 150 of them in the last 3-4 days who have joined that group, and we hope that number will increase quite fast. So give your viewpoint on that.
Yes, I think the scale that we are talking cannot happen by doing a lot of activities. I think every institute, I talked a bit, maybe 35 plus institute I have interacted with last 2 years now, coming here. Before that, I have got to interact with 40 plus institutes. We tried to copy this model, not copy, I would say, replicate the model of BB College. In 100 plus colleges visited college, only 5 colleges started the model. And which college started? The board member visited Hubli, those colleges only could start this model. So it's a very clear that it's not going to happen unless the board, principal, HOD is aligned. So scaling requires actually like-minded startups, industry, academia, working together and doing activities towards outcome-oriented. There is a story, 90s, we used to have a good hockey team. They used to get 8 to 10 penalty corners. Okay. Unlike maybe Australia and others, they will get maybe 3 or 4. But Indians could rarely convert that into goal, whereas Australians could could get few penalty corners, but the outcome, they had an expert to convert into goal was high. In India, I'm making a controversial statement in front of all academicians here. We have hundreds of activities. We are working in hydrogen, electric vehicle, industry automation, agri-tech, medical, healthcare. And all these activities happen. All conferences people are joining, all papers happening. One faculty is working in the same department in cryogenic, one is working in plasma, one is working in other areas. They together don't solve a problem. Everybody is working on the technology, vertical. No real problems are solved. That collaboration has to start first. And that collaboration has to start on a common goal, not on basically I'll do something, we'll do something, and just as a kind of we are collaborating for talent development. After 1 year, it will be gone. Okay, when the interests are gone. So we have to solve a problem, interdisciplinary problem, using everybody's skill and create an outcome. Once that starts happening, other faculty, other students, they start doing that, and collaboration starts in the campus first. If you can't collaborate within the faculty to solve a problem, you cannot collaborate with startup, neither industry, and that's a problem. So collaboration is missing today. Neither industry know how to collaborate with faculty or colleges, and they don't have strategy, and college doesn't know. So that's why we are looking at a product nation initiative we have started now. What we did in BB College, we are working on that way. But students are the crux of it. I was talking to Jhunjhunwala, Padma Shri Ashok Jhunjhunwala, and you are saying that, hey, what you are doing is good, but focus on students, he said. Students are the transforming agent for product nation. And students who are actually in the first and second year should be passionate about their core. And that will change in next few years. But today, many students are taking core job not because of they are passionate, because they are not getting IT jobs. I'm just being honest about it. Okay, I'm talking to me. IT jobs have gone down. Earlier time, students used to come to electronics or mechanical because they are passionate about it. Today, they come to electronics and mechanical only because they didn't get job in the IT. I think that change has to happen from colleges. Colleges have to create those opportunities for students to get jobs in good companies through an industry academic collaboration. So student clubs are most important. Only suggestion to students is don't solve trivial problems, which are demo problems. Talk to industry, connect to your alumni, ask them real problems, understand real tools, and solve a problem which is real. That will give you the skills to get a job or even create a product and create a startup. Okay, that is most important.
So since you talked about students, I had actually asked them if they had any questions. So I'll just ask a couple of questions which they have asked. So one of the questions they are asking is if they are less, the youth, people with less than 5 years experience, can they still make a big impact in the India Semiconductor Mission? That's number one question. Second is how can they participate? We are all talking and discussing, most of us have gray hair. Can they participate in the scaling up effort itself? How is the mechanism to involve them? Maybe Mariam and Bharat can take one part of the question, and maybe Sudarshan, you can also address the other one on the ISM. How can students participate?
So I think we are a slightly misplaced conception about semiconductor. Students feel that if I do a semiconductor tool, I understand the tool, I do some kind of a student have to first understand how to do an electronic system, because chips are actually nothing but representation of system. If they don't understand electronic system, they don't understand how to kind of use the microcontroller, sensor, actuators, and solve the real problem. If you do a chip, you are doing a block which is useless. What did you do RISC-V for? Have you optimized RISC-V for the electric vehicle, for automation industry, or something kind of a healthcare with a specific problem solved? They won't be able to do that unless they understand electronic systems. So my request to student is, even if you have a club, start doing small modules of VLSI, but understand how to build this module. You all, if you do system design and start doing small modules, because chiplets are coming, and chiplets are actually nothing but building chiplets and creating system again. So you can have all aspect of chip design only when you have system design capability. So start with system design, then the module design and chiplet, and you will be able to contribute.
Yeah, so I'll address some of the earlier one also. In fact, Professor Mariam talked about scaling out, but with quality. And yesterday evening, Jaya Madam had called. She was talking about scaling up. to the extent of even 3 nanometer. So both of them, I think the point Vivek raised also is related to understanding one is the fundamental innovation. In IT, if you really look at it today, India do not have large number of software products. Not because we don't have programmers, because we don't have software architects and software engineers. We have programmers. That has resulted in we doing a lot of coding, somebody owning the product because they have architected, they have made a solution. Semiconductor, I think that lesson has to be taken up seriously. We have to teach not just the EDA tools. We have to tell them two parts. One is the material science and physics part of it, so that they understand the chip design, why a design is being done like this, how are we doing the placement routing. Sincerely, in my experience of campus hiring, even people with 1 or 2 years experience, today they cannot answer the difference between digital and analog ground, in spite of being in the industry. Students attribute why they have to learn. It is not because of the mark. If you don't do it, your system will fail. That the way we teach, mentor, coach has to be a little different. That is one aspect. The second aspect is, without naming, one of the first few designs we received for tape out. The professors had taught amazingly. Students have designed the chip. Finally, it came up, but it does not even have pads for pins, because functionally IP designed, simulated, working fine. They want us to fabricate, which cannot have any connectivity. So forget about even knowing the system, even the knowledge, the faculties, because they did a PhD with a professor abroad for a particular theoretical concept. Unless you have the habit of developing one chip, seeing it yourself, it's very difficult to teach, because I have not gone through it. Perhaps there is something for us to learn from Europe. To be a professor, you must have been with industry for 10 years, or you should own an industry. Otherwise, you don't become a professor. Be one glare, be teaching. Something like that we have to do. But coming back to ISM part of it, the CTS has got 4 types of institutes that are given support from. In that, one type is called Tier 1 or Type A, where a consortium of 1 startup and up to 4 institutes with the lead institute have to come. So there is a startup, there is a targeted product outcome, and the whole team has to work together. So theoretically, the lead institute takes care of the academic part, and the startups looks at the use case and the marquee customer with whom the product can go. That ensures real product, some quality, some cost metrics in place. Then we are talking about an engineering solution that is economically viable. This is in place. Now going forward, we are going from fabless. Last December, we have revised the mandate of C2S, where now we are going to enable peripheral IPs so that they know how to interact with my development with the rest of the ecosystem. Interaction, we will be acting as a value chain aggregator, where the designs are put up and we are tying up with foundries, so that prototyping can happen at a reasonable cost or affordable cost. Otherwise, to tape out a chip is very difficult. And more we are finding, given the India's diversity and consumer market, we may end up focusing more on analog and other kind of design than the traditional digital design, because most of our IoT and smart space that is needed for the country for various things, including AI data inputs. They are trained based on sensors. Probably analog is coming back big time, partly because of HPC, partly because of quantum, partly because of the sensing needs. It will also reduce the energy part. We are looking at energy in a big way. The fundamental part now we have to look at is, instead of everyone doing identical things, we have to micro service type. Somebody has to focus on RF in a particular segment. Somebody can focus on mixed design particular segment, cryogenic given the quantum a particular segment, photonics for a particular segment. So if we subsegment it, it will not be a mass production at an average level, but we can have multiple verticals, each one bringing enough talent so that that industry can groom. That is what he was also saying. Let us focus on one industry and the industry collaborate. The last part is for an academic institute. If we change, some institutes are actually offering entrepreneurial track from second year. They don't do traditional project. They decide on a entrepreneurial track. So they are given course on managerial economics and things like that, and they have to come up with a solution. But this should be augmented by one thing. No student can do project from students from the same department. The only way we can encourage engineering solution coming out of engineers is at least 3 departments, not IT, e-commerce and computer science and computer data science, no. Circuit branch, mechanical and civil branch, electrical branch and computer science, maybe MBA. There has to be 1 student from each of them mandatorily, and what should they give in the product should be a solution, not a project report and a demo. If we do that, India will completely change, is what I feel.
Yeah, I think we've got a message to wrap up, but
I think just for students who are doing the club, right? You have around 25, 30 members. Divide the team into 2, 3 teams. One does the chip, basically. One does the system using the chip. And one actually does the testing. So I think we have to make sure that chip is not important. Important is when the chip is made, is it working, and then how to test it. If that whole cycle is not there, the learning is very incomplete. And you learn a lot from the mistakes you make. And only when you test the chip, you'll know where you have made a mistake. So it's important that pick up one vertical segment, one problem, and whole club can actually solve that problem. Could be a problem in the college itself. College will still have, could be water level controller, whole system for that, efficient power management. Maybe could be a flow controller, could be a kind of a pollution meter. Pick up one area, all of you become expert in that. Once you are able to go depth and solve any problem to the depth, then any other problem, you can go to the same formula and solve that, and you'll become expert.
okay, thank you, Vivek, and let's give a round of applause to the entire panel for some wonderful insights, and I'm sure a lot of the points they have shared can directly flow into some of the discussions and deliberations the teams are having in their respective colleges about how they should form up the clubs, also how they can leverage whatever IIT Bombay and CEMIX is put together, and various things which are already available in this ecosystem to tap in. So thank you again. Wonderful having you all.
Yeah, just one thing, since IIT Bombay came multiple times, in the last time, most of the academic, the tape-out chip happened. IIT Bombay had several chips that were taped out from higher nodes beyond ACL. So definitely they are one of the leaders when it comes to that.
Thank you so much. A very, very insightful conversation. May I invite on stage Mr. Sanjeev Keskar to please felicitate and thank the speakers. To Mr. Vivek Pawar. Mr. S.T. Sudarshan. Professor Mariam. Mr. Bharat Agarwal. And to Mr. Dinanath Kholkar. Thank you once again. We'll have a group picture, please. So please do. We'll have the valedictory session now. I'm asked to wait for just 1 more minute before they set up the stage. Speakers, just 1 minute more. We'll start the valedictory session now. I request the speakers to please join me on stage. Mr. Ajay Bhagwat. Mr. Ajay Bhagwat, owner Renu Electronics. Mr. Achok Chandak, President IESA. And Ms. Jaya Panwalkar, former Senior Director, NVIDIA Graphics. This is the valedictory session. We will have networking time after this session. I request Mr. Ashok to please lead the conversation.
Hi, good evening, everyone. So, as the sun sets onto the illuminating day which you had today, आज आपको बताएंगे दिन भर क्या हुआ और आज आपको बताएंगे आगे क्या करना है. Now I can read your faces. I don't think many people got what is the meaning of Aaj. Aaj is AAJ. A for Ajay, A for Ashok, J for Jaya. That's Aaj. So what a great day actually, multiple sessions, particularly 4 of them, starting with the fabs and all those things. But I want to just take a step back. And I want to bring to your kind notice that the most buzzing word during last 1 month in the country is semiconductors. And I'll give you statistics. 3,886 articles have been published in a print and online media. More than 180 TV channels have published the stories on a semiconductor sector last 1 month. So that's the thing which you can imagine where we are actually. The sector which is buzzing with the, not only the name, but also with the opportunities. And many of you may be going to smaller towns or villages and put the word semiconductor and you will find that many people are aware of this word now. Because just 2 weeks ago, I went to one village and people were asking, semiconductors, wow, you are in a great field. So there are a lot of opportunities for us. Whole day we have discussed those things. And I know it's the end of the day, so we'll keep it a bit short actually, in terms of looking into how we go forward. So these discussions were not only concepts, but also we have done a lot of architecting of the ideas during whole day, starting with the beyond fabs kind of a concept. And it's indeed the point actually. It is not only a question of the capex, which goes into billions and billions of dollars and associated industries. And building that is also quite important stuff, and particularly the semiconductor ecosystem as the title of the conference is. But also the most important topic there is in terms of the design topic actually. The design, the product creations, the fabless and other stuff. So first I want to bring Jaya ji to put her views and also additional topics related to the semiconductor ecosystem.
Hello, good evening, everybody. I know everybody is waiting for tea and ending this session. And I hope that we 3 are not going to take too much time out of you and tea in between that. So one important thing that he said about fabless and fab and everything, there was earlier session when Vivek was saying everything about doing a system design with at least 3 engineers coming from 3 different disciplines and doing it together. So one of the things that I am going to mention is that there is a lot of market, lot of requirement for fabless design. One of the important things is that we can have a few fabs. But to keep the fabs busy, it's very important that we have the designs ready. We have the fabless designs ready for that. And that is very, very important. And what is a fabless design means, it is not just the netlist. One of the important things is that you do first the system design, then you decide in the software or maybe in the digital twin what are these functional aspects, what is the goal of the chip, and what goal it is satisfying. Then you have to go for what will go in the hardware, what will go in the firmware, what will go in the chip, whether it will go in one single chip or in multiple chips, whether you will have multiple IPs, and all these things together, when you connect together, then it becomes your fabless design. And then you go for the use of the tools. So one of the most important thing is that so many things happen before actually the actual use of the EDA tools. So sometimes we feel that, okay, we don't have tools, that's why we can't do the things. But there are too many steps before the tools are used. And when the tools are used, the things are that you need to know little bit or more things about the material science. Because you have to decide during the fabless phase only what type of materials, what type of chipsets, what is going to be in IP, all that beforehand, and therefore knowledge of the materials, knowledge of the chip fabrication process, maybe multiple chips one on top of each other like NVIDIA produces these days. I'm not going to talk about NVIDIA here. We know that there are very much at the higher end of this, but we will soon be reaching there. Our goal should be to reach there someday. And that's why actually I mentioned, but it is that important that we have to design all these things beforehand. And therefore, I just wanted to suggest that we need to concentrate, maybe 70% or 80% of our revenues will be coming from fabless designs. That's what my thought is.
Thank you, Jayaji. So just like semiconductor is a buzzword in India, there is one company name which is a buzzword all across the worldwide, actually, globally. One chip company. Can you figure out the name of one chip company which is creating a buzz worldwide? She is the first employee of NVIDIA in India. So the entire setup of NVIDIA has been done by Jayaji, and we are really fortunate that she is with us today over here, where the companies are built. It takes time, actually. One of the also important aspect, and I take it from her actually, is fabless is quite definitely important, and it also needs some additional nurturing. So we have this DLI scheme running from MIT, Design Link Incentive, and Sudarshanji was here. Where is he? I think he's gone. Oh, he's here, yeah. So CDAC is actively involved in promoting that DLI scheme, which is already benefiting large pool of startups and part of DLI, that C2S scheme. So this is progressing. There is a DLI 2 is going to happen. Fabless is definitely important aspect for the country, no doubt about it actually. And all of us, including ISA as a body, MCCI, would get involved. And very soon we are working towards setting up one VLSI incubation center in Pune. So that would happen. This is just a work in progress right now. Final blueprint and approvals are in progress. The second important point was during our today's sessions, there was one topic about the global alliances and cooperations. And many times, you know, people misuse the word self-reliance, particularly in semiconductor industry. Self-reliance doesn't mean that everything you are doing on your own. Self-reliance doesn't mean you are limiting others. This industry is highly global in nature, actually, both electronics and semiconductor. And then multiple countries need to work together, and we put a definition as self-reliance from semiconductor perspective is more of a strategic interdependence, where there are multiple countries, multiple entities are getting involved in electronic industries. And one of the challenges has been on the product creations and product development. So, you know, many of you, those are in Pune, they are aware that there is one particular road in Pune where there are large pool of startups actually. What is that road name? It's called Baner Road. So, you know, we had one gentleman who has an office in Baner, but mostly he is running across the globe. He was running around Germany somewhere. We requested him, he is back here. Let me get Ajay Bhagwat, who has been one of the highly successful company in electronic sector. And I would request you to give your advice, your views, what could be done more based on your learning experiences, particularly on electronic systems, electronic products, components, and other stuff.
Ajit, for organizing such a wonderful conference. In fact, I noticed the title called Semiconductor Ecosystem, So an ecosystem is an interesting word. It's about collaboration. It's about multiple people doing multiple things and still coming together for one common cause. And when I was chairing the electronics committee at Chamber of Commerce, we realized that, of course, electronics and semiconductors, they can't be separated from each other. Frankly, the goal of semiconductors is to serve the electronics industry, and then, of course, vice versa. I wanted to share three things, Ashok. One is how an ecosystem can be built, and we have a very good success story with MECF, which is MCCI Electronics Cluster Foundation. The concept there was very simple, that there are more than 1,000 companies in Pune. How is it that many of them are not able to access the global market or in general scale? And we found out that a large portion of their challenges included not having access to tools, design tools, testing, verification, certification, etc. So they could never scale their own market beyond their own neighborhood. And when I was looking at our own company, and we scaled because we serve the global market. So we came together at the Chamber of Commerce here, and we said, let's do something about it. And we actually created the country's first cluster under the Brownfield Cluster Scheme, and it's a great success story. Over the last, it's taken a long time. It took almost 8 years before it saw the first customer. But it took a 70 crore investment. 50 crore came from Government of India, and 20 crore came from industries like you and me. So what I'm trying to say is that such a thing is possible. We always said jokingly that in Pune, there is no way people will come together and contribute to a common cause, but it happened. We actually have a cluster, beautiful cluster. Those of you who haven't visited, I would urge you to see what we have been doing there. Now, all the world's latest facilities for testing, all sorts of testing, whether it is EMI, EMC, environmental, materials, etc., we do there. Why am I saying this is because it shows that if multiple people come together, we can actually serve a common cause. And in the last 1 year, I'm told that several hundreds of SMEs have actually used the facility. And I'm sure it eventually will see a success of the electronic industry in Pune coming from that. I'm sharing that because I want to connect it to the semiconductor ecosystem as well. Yeah? So in the semiconductor ecosystem, and this follows the visit by the Honorable Minister for Ministry of Electronics and IT. I mean, we are having this conversation. We said we are very happy to see all the progress that the country is making, and thanks to CDAC, Mr. Sudarshan is here, great work being done. The question, however, is can we think about creating commercially successful chips coming out of India? What I mean by that is, if Radio Electronics wants to do the next generation human-machine interface, can I think about buying a chip that was designed and manufactured in India? And at this time, unfortunately, the answer is no. And we need to get there. It's not going to happen overnight, but we need to get there. Now, something like that requires, again, an ecosystem. What I mean by that is a company like mine or a company that manufactures, let's say, pick any example which has significant volume in India, whether it is electricity metering product, whether it is solar inverters, whether it is, and I can give multiple examples where there is a possibility of necessary volume coming out of our own country. And then, of course, there is a market outside of India that's also available. We don't think about making our own chips for doing something like that, even though at the end of the day, it might make economic sense to do it as well, but we don't do it. We don't see a brand coming out of India which sells commercially successful chips worldwide, like Ashok, you know NXP very well, ST Microelectronics, Microchip. We don't see an Indian brand looking at products. Why is that? I'm sure there are reasons for it. And again, it requires an ecosystem. Then, of course, we have a large number of companies which are capable of, they have the resources to do the design of something that can be simple or complicated. A lot of GCCs are here, a lot of talent available. So, what's missing here? What's missing, in my opinion, is to bring all of them together under one platform. And that's what we are actually working towards, and we promised the minister that time that we will help the government of India and CDAC to come out with something that we think as a consortium can be commercially successful. So it's not, I mean, I'm fully aware that we're not going to see results overnight, but it has to be a vision that spans over the next 3, 4 years, 5 years, etc. But we need to come together and do it. And that's what we are actually putting a proposal together. What's in it for us? Basically, a company that wants to design a chip like this or for their own use or to sell it to the global market, will they get access to the DLI incentives? Can the access to tools and IPs be made available through cooperation with CDAC and MET? So can we really look at benefits to the ultimate stakeholder which wants to own the design or the chip? Can that, and again, there is a huge trust deposit with MCCI because of the success of MECF. MET would be very comfortable working through MCCI as a consortium, and we think we can make it happen. You know, that's the. So I think the ecosystem part is something very important. We need to make it work. The third very important, you talked about products. You know, you talked about why, and you also mentioned being successful. You need to be able to conceptualize and design a product. Now there are multiple things here. In the ecosystem, I'm not even talking about the fabs which are going to be manufacturing the chips, but at the end of the day, somebody still has to have the ability to define what we want, ability to control how the design is going. So the program management, yeah, you talked about the whole process, and it's not a trivial process. Because we haven't had too many success stories, entrepreneurs typically shy away from thinking about making myself. I mean, if I were to make a chip that requires maybe 10 million pieces, I might unfortunately feel comfortable buying it from an established brand rather than thinking about doing it myself. Why? Because somewhere down the line as an entrepreneur, I think that, okay, I'm willing to spend $10 million on it. 10 million is not a problem. The problem is, what if it fails? That's where the real challenge is. And that's where all of us have to come together, and mentorship from people like you who have successfully done this, companies which have done this for other customers. We need to all come together and figure out how to make it happen. And the next, that's what will allow even the investor community. I've been speaking to a lot of investors about this, and quite a few of them are shying away from saying that, oh, product karna hai, so maybe it's a dangerous investment. Maybe I may not see the return on investment, etc. I think success will breed success. And I'm quite happy to start with something that's like a lower hanging fruit, something simple. It's okay. We can start, I don't need a 3 nanometer design today. I don't need to manufacture something that is complicated today. Maybe 5 years down the line, we will do it. Start with something simple that has applications right away. I remember the case in my own company where we were making a large display product, and there was a Chinese. When I had a complete Linux-based solution with all the chips and memory and everything, our competitor had a single chip that did everything, and all they had, that chip, the display, and power supply, and that's it. No wonder their price was low. Not because they were doing any cheating or anything. Their price was low because they were highly innovative. They were willing to invest. So, and this was a product similar to what you see in your houses, like your video door phone. Why do they sell for less than $30? Because of this. If you have to compete globally as an electronics company, we must be able to do something similar, be able to take the risk, spend the 10 million or whatever that money is, but then generate a $100 million business out of it and make it up. This is how I would say my vision of the ecosystem that we can build in Pune. And although I'm not an office bearer at MCCIA, but I work very closely with the MCCIA as part of the MECF as well as the Electronics Committee. And we want to take it upon ourselves to build such an ecosystem for betterment of the Pune industry to begin with, and of course India as a larger goal. So this is my view on this.
Thanks, Ajay. Incidentally, me and Ajay were working almost 10 years ago regarding this Pune electronic manufacturing cluster topic. So one of the sessions during the day was scaling going on actually. And if you get reminded a bit, chips are digital diamond. Who said it? Modi. So let me ask next one. If chips are digital diamonds, engineers are jewelers. Who said it? Me. So joke apart, that's how the industry is actually. I mean, the engineers have got such an important role to play, which is not because all of us are engineers actually by definition or by degree, maybe most of us, but that's what it is actually. And what Bhagwat narrated and what Jayaji narrated as a fabless, which is the design aspect and also the product creation. This is all engineering skills. Those are quite important and would be useful. And this product creation is the most important thing actually right now in the country. We are running an initiative called Making India a Product Nation. And you will hear this phrase from even Mr. Ashwini Vaishnaw, our union minister, and various mighty people, including ISA. We have started promoting that concept. With MCCI, we have started discussion on the same topic. As because if we make really a product, that's where you retain the economic value in the country. Otherwise, we are just doing the assembly activity. So coming down to, I will just take maybe a few more minutes at the end of the day. We're talking about the scaling to skilling. And Jayaji, can you tell us something about from a high-performance computing perspective, which will also be involved heavily into the next generation AI-related topic, those going to influence everybody, every aspect of the life? What is going on in the high-performance computing-related skilling topic particularly?
Yeah, actually, I am working on the National Supercomputing Mission for last 7 years, which started in 2015. And I am chairing the reskilling and upskilling of the talent all over India. And I'm chairing that group. And with my 7 years experience in doing this, I have realized one thing, that when you require top skilling and upskilling, your mindset should be ready to learn, not the tools, but to learn this behind that, the stories, the applications, the uses, the quality, the productivity, and also in which market the solutions are going. I have seen that when I was doing this upskilling and reskilling, I have realized one thing, that unless and until the faculty of the colleges learn the things which are really required to be learned in the new domain, the reskilling doesn't happen. Now, talking about the high-performance computing and AI, now the second mission for high-performance supercomputing mission is going to start soon in January 2026, where in the first mission we have installed 37 supercomputers across the nation. And those are apart from the supercomputers installed in IMDs and in defense organizations and ISROs and other things. They are only purely for the research and development and small technological labs for development, like TIFR's NCRA lab, IUCA lab, and those kinds of things. So one of the things is that we have installed about 50 petaflop machines across the systems. Now in the next thing, equally important is AI. All the machines will be now not for the only high-performance computing applications like weather forecasting, but also for the applications like driverless cars. Maybe our systems, our people will develop driverless car solutions with fabless chips and give it to the other nations before the fabless cars comes over here. So that is one of the very important things that I wanted to say. And that AI chips are also required to be developed in India. So I agree with Ravi, Ajay, that we have to look for the low-hanging fruits today. But our aim should be at much higher range. And for that, one of the things that is very important is that proactivity, ownership of whatever we do, and the quality aspect of whatever we deliver.
Thank you. So I think we're coming to end of the day, closing this now. And we had a day which is full of multiple sessions, but there are, typically I could see there are 4 sessions, beyond the fabs, then the global partnerships, the manufacturing, how to strengthen, and scaling the scaling, whatever, my joke. So there are 4. And I realized these are the 4 important pillars of our entire semiconductor ecosystem development. So first of all, I want to really give a big thank you to the organizing team, MCCI and STPI. Ajay Srivastava is here, and Sanjeev Keskar, the convener of this event, to really very carefully and very well articulating these 4 pillars. Those are covered into the full days of discussion. That's very important, and thank you very much. We also have to thank all of you actually as an audience, those who have spent a full day into this particular building, which is into this building and this particular room, not only doing your additional kind of a learning activity, knowing what's going on, but also networking and meeting and greeting each other. And that is also, I also came for that only to meet many people actually. Otherwise, in a day-to-day life, it's very difficult to catch up with people. So thank you all of you for coming over here. Also, we have to thank our speakers, the panelists, those were present, and they traveled all across the world, including Ajay came just today morning. Today morning only he returned from Germany. And there are several speakers, those came from outside of Pune, for example, Mr. Sudarshan is coming from Bangalore, and other guys, even there are a few more people coming from Bangalore actually. So that's really, I have to say, thank you. I'm not doing vote of thanks, but as a validatory session. So I must appreciate efforts done by all these people actually over here. And I think I would say we had a really great day. Really looking at the architecting, what needs to be done in future, not only looking at what has been done so far, but really defining the architecting it. It's not a question of only theoretical topic, but a vision, but also getting into the reality and real outcomes. And as I mentioned, this is the most buzzing sector right now. The semiconductor demand in India today is about $55 billion this year, going to grow to $103 billion. Again, who said it? You can take my name, because I signed that report actually. So that's a $103 billion semiconductor demand growing. Electronics side, actually, we are looking at about $180 billion as electronics manufacturing in the country this year, which is going to grow to 400 billion plus by 2030. And when these things are growing, you know, all of us have got an opportunity to participate over there. And before I end, I want to give you one example, how our country's Prime Minister thinks. I think you have heard it in multiple speeches and other things. I had a very unique experience actually. Last month we did this Semicon India event, and Honorable PM came twice actually for that event. He doesn't go to any event 2 times actually, by the way. So Semicon India event, he came twice. You might understand the importance which is being given to this sector. And then when he was onto the exhibition tour, I was standing in one of the booths, and Ajay, you referred about the smart meter chip. So one of our startup did the smart meter chip, which was demonstrated actually live to Honorable PM. And you know, he asked one question, and see how the people think. And I was really amazed by that. He asked a simple question. He said, "A smart meter chip तो आपने बना दिया, लेकिन मेरे किसान भाई, मेरे गांव के लोग सोचते कि स्मार्ट मीटर चिप लगाने से उनका बिल बढ़ता है। तो आप ये बताइए लोगों को कि ये स्मार्ट मीटर चिप से बिल नहीं बढ़ेगा, उनका क्या फायदा हो?" See, this is the real point actually. I mean, we miss. I have been involved in the chip design, by the way, and into selling the smart meter chips. Never this topic we covered actually. We just look into, this is how you have to look at actually, that the end guy is, if they are not convinced, they are not happy, and that is a fact. I think we keep reading into the papers also that people saying, "Arey, smart meter, mera bill बढ़ गया. So, and this is, I'm not joking actually, this is a fact. He has this question. We have taken the action. We have given one narrative also now as how smart metership can be beneficial to the farmers and to the other people actually. So the country is going in a very fast way in a different direction, and many of you are witness. I want to only say that we are in the right sector at the right time. We have a good opportunity for all of us. And with that, I would end up my valedictory session and over to the convener for next phase of the session here. Thank you.
Thank you very, very much. It's really the urge of today and a very strong valedictory panel for this. We have Ashok, Ajay, Jaya, the urge. So I request Mr. Sandeep Gupta to please felicitate the speakers. Ms. Jaya Panwalkar, ma'am, please. Mr. Ashok Chanda. And to Mr. Ajay Bhagwat. May we request a group picture, please? You may please step forward. Thank you so much. With this, we conclude the event here. We invite all of you to join the networking over tea. It was a great day hosting all of you. We're grateful to STPI to co-organize this event with MCCI. Thank you so much. There is a request. The organizing committee, please join us on the stage for a group picture. The organizing team members, please join us on stage. All those who have contributed for this event, please join us on stage. Prashant sir, Prashant Jogaikar.
Hello. Ajay ji.